Ever stop to think about what Albert Einstein has to do with you finding the nearest coffee shop? It sounds kind of crazy, right? But it turns out the phone in your pocket, the one you use every single day, relies on some of the most mind-bending physics ever thought up. So let's break down exactly how. Okay, so here it is. This is the big secret, the whole reason we're here. Your GPS only works because of a truly bizarre fact about our universe. Time isn't constant. It's flexible. And for GPS to work at all, we have to account for time running at two completely different speeds at the exact same time. Now, how is that even possible? To get our heads around this, we've got to start with Einstein's first big idea about time. And believe it or not, it all comes down to one thing: motion. The key concept we need to understand is something called time dilation. Yeah, it sounds like it's straight out of science fiction, but I promise you it is a very real, proven physical thing. Simply put, it just means that time isn't some universal clock up in the sky taking the same for everybody. Your experience of time literally changes based on how fast you're moving. You know, the main takeaway from special relativity is actually surprisingly simple. It's really just a trade-off. Think of it like this. We're all moving through this thing called space-time. The more of your cosmic speed you use to zip through space, the less you have left over for traveling through time. So yeah, a moving clock literally ticks slower than one that's standing still. Now, this whole idea leads to a really famous thought experiment. You might have heard of it, the twin paradox. So one twin stays on Earth, and the other one blasts off in a rocket at nearly the speed of light. From Earth, it's obvious, right? The rocket twin's clock is running slow, so they'll come back younger. But wait. From the rocket's point of view, Earth is the one flying away at high speed, so the Earth twin should be younger. They can't both be right, can they? And here's the solution. The tiebreaker, the one thing that makes all the difference, is acceleration. See, the situation isn't symmetrical at all. The traveling twin is the one who has to physically speed up, turn around, and slow back down. They feel those forces. That act of acceleration totally breaks the symmetry. And it proves, when they finally get back, the space-traveling twin really will have aged less. So, no paradox after all. Okay, so that's how speed messes with time. But that's only half the story for our GPS. Now, we have to bring in Einstein's other big theory, general relativity, and talk about the second way time gets warped, gravity. And this one is just as wild. According to Einstein, gravity isn't some invisible force pulling things down. It's actually a curvature, a bend in space-time itself. A massive object like our planet creates what you can picture as a gravity well. And the deeper you are inside that well, the slower time itself passes. So a clock at sea level literally ticks slower than a clock on a mountaintop. And this just brilliantly shows you the real-world effect. I mean, the difference is super tiny moment to moment, but it's real, it's measurable, and it absolutely adds up. Over the entire 4.6 billion year history of our planet, just that little bit of altitude between sea level and the peak of Everest would create a time gap of 39 hours, which means, and this is wild, your head is technically aging faster than your feet. Okay, so now we've got the two key puzzle pieces. Speed slows time down, and weaker gravity speeds it up. Let's see what happens when you apply both of those to a GPS satellite whizzing around the Earth. GPS satellites are basically caught in a constant relativistic tug of war. First off, they're moving incredibly fast. We're talking about 8,700 miles per hour. So, as we just learned from special relativity, that high speed makes their internal clocks tick slower than ours down here on the ground. But at the same time, they're 12,550 miles up, where Earth's gravity is a lot weaker. And general relativity tells us that this makes their clocks tick faster. So, which one wins? Well, the numbers tell the story. The speed effect, it slows the satellite clocks down by about 7 microseconds every day. But the gravity effect, from being up so high in a weaker gravitational field, that speeds them up by a whopping 45 microseconds per day. So yeah, it's not even close. The gravity effect is way more powerful here. So when you do the math, 45 minus 7, you get a net gain of 38 microseconds every single day. The clocks up in orbit are constantly running just a little bit faster than all the clocks down here on the ground. And that might sound like a tiny, insignificant amount, but for a system that needs nanosecond precision to work, it's a catastrophe waiting to happen. So, what does this 38 microsecond problem actually mean for you trying to get to your destination? And how on earth do we fix it? If we just ignored this tiny 38 microsecond drift, the errors in your position would add up at a rate of about 10 kilometers. That's over 6 miles every single day. After just 2 minutes, your GPS would already be telling you you're somewhere you're not. The entire multi-billion-dollar system would be completely useless. The solution is just an absolute engineering marvel. First, before they even launch these satellites, the atomic clocks on board are intentionally designed to tick just a little bit slower than normal. This pre-correction accounts for most of the speed up they're going to experience in orbit. And then, once they're up there, ground stations are constantly checking in, sending tiny adjustments to keep every single clock in the network perfectly synchronized. So the next time you pull out your phone to figure out where you're going, just take a second to remember what's happening thousands of miles above your head. And this is really why this all matters. Einstein's theories aren't just some abstract, weird ideas for physicists to argue about in a classroom. They're literally woven into the fabric of our daily lives. They prove that our gut feeling about time, that it's this constant, universal ticking clock, is just plain wrong. The universe is a much stranger, more flexible, and honestly a way more fascinating place than we usually give it credit for. Over a century ago, Einstein's old teacher, Hermann Minkowski, said this. He was one of the first to realize that we just can't think of space and time as separate things anymore. They're a single, unified fabric, space-time. And it's only by understanding this fundamental union that we can navigate not just our world, but the cosmos itself. Makes you wonder what other huge secrets are hiding in plain sight, doesn't it?